All right, let's talk about the boiling point. Boiling point, just like melting point, is a physical property. Doesn't matter if you have a gram or 100 grams, a bucket or a cup of water. Water boils at 100 degrees Celsius. So this is going to be key for you. You will be given four unknowns, and you have to again run your method, run your experiment in duplicate. And then you would take the same unknowns and you would predict. You would determine, first of all, you would determine the eta, refractive index, and then you would predict the identity. That means from the table, you would have whether unknown one is acetone or based on both the values that you get. So it's really important that you do a good job with recording all of your data together. The setup for boiling point, we are going to do that in the hood, and I would encourage you to have each hood dedicated to a certain temperature just for the time piece of it. Otherwise, you're spending more time in heating and cooling the bath than otherwise. These are nothing but water baths. We can absolutely have silicone baths too. So if my boiling point was higher than 100 degrees Celsius, then sometimes we would have an oil bath. You can use oil bath or water bath, but as you know, water boils at 100. So that's a limitation, that if you use a water bath, it can only go up to the 100 degrees Celsius. So you would have the little containers, little dishes. You're going to set up a hot plate. You're going to heat it. So the heater part of it should be turned on. You would have stand. This contains the oil bath or water bath, as the case may be. You would have your clamp. You would have your test tube, and you would fill the test tube with just about a milliliter. So you don't have to fill it in completely. Just about a milliliter of your unknown. So let's say you have unknown, and it's unknown 1 you're looking for. You're going to take a capillary tube and you're going to invert it, and make sure that you have a thermometer. So thermometer is essentially outside, measuring the temperature of the bath. And that's your setup. The whole idea being that as you heat up the sample, the vapor pressure inside the capillary is going to start to build up, and you would see a bubble each time as the temperature rises. Each time you would see like gentle stream of bubble that will generate. So bubble 1, bubble 2, bubble 3, you would see that. As you get closer to the boiling point, it is going to become rapid bubbling. And at the boiling point, the entire air in this column is going to get displaced, and you would see that the liquid is going to rise up. That's where you need to stop, and that's your boiling point. At this point, you would also see that your thermometer will show a constant temperature, and that's it. So again, you have a water bath, you have 1 milliliter of sample, inverted capillary tubes. You have 4 unknown samples. You would make a table, you would tabulate that, and then you would carry on with the eta, with the refractive index. So let's take a quick look at that. In case of refractive index, I'm going to just see what you're going to see. Basically, you would get two windows, okay? And like that. The top one has an X mark, and it has this region of darkness and region of brightness that that we are looking for. You want this midpoint of the region of darkness and the region of brightness. You want the midpoint of that to be passing through the cross section. On the bottom scale, you have numbers. So let's say this was at 1.33, this was at 1.34, and then there are 1, 2, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say your vertical cursor, it kind of cuts at the second place. Your reading becomes 1.332. It will cut a lower scale at the bottom. Maybe the numbers at the beginning are 30 and 40, and there are 10 divisions. The bottom scale is called as vernier scale, and the top scale is the metric scale. So you want to get the last two decimal digits from the vernier scale. So let's say it cut at 30 exactly, you will say 30. So again, first two decimal places, they come from this piece. The third decimal number is where it cuts the metric scale, and the last two come from vernier scale. And that's your reading. You do this twice. You do this for all 4 of your samples, and then you make a prediction as to what is your product. That means you identify your compound, unknown 1, whatever the identity, unknown 2, whatever the identity, so on and so forth.